Today we will start with bus structure of 8085 microprocessor. See, what is bus actually? If you can see this diagram, in this is 8085 microprocessor chip. Okay, so this 8085 microprocessor chip is of 40 pin, 20 pins this side, 20 pins this side, just like your basic IC structure of AND or that we have already seen in 11th standard, right? That was a 14 pin IC. If you remember the IC structure AND gate or gate, that was 14 pin IC, 7 pins one side and 7 pins another side. That is 40 14 pin. Now 8085 microprocessor is 40 pin IC. Microprocessor 8085 microprocessor is 40 pin IC. So this 40 pin IC, 20 pins this side and 20 pins this side, and this structure is called a tip structure, dual in-line package. Okay, so this microprocessor is now connected with different external devices like memory, input and output via some connecting lines, and these lines are called bus. See, these input output memory, how they will interact or how they will transfer their data, and if microprocessor wants to communicate, how they will send the address. So everything should be connected, and then these all things are connected via buses. Okay, so bus is a group of conducting wires which carries information. All the peripherals are connected to microprocessor through bus. So we will learn all the buses based on 8085 microprocessor. So we have three types of buses: address bus, data bus and control bus. So we have already done little bit in 11th standard about the system buses. So now we will study all these basic buses based on 8085 microprocessor, right? So in this, next is address bus. Now, what is the meaning of address bus? Address bus is basically carrying address. So this is the basic function of address bus, that carries the address. Next is address bus is unidirectional. Now, what does this meaning? The meaning unidirectional means it always from one. It is in one direction. It is always from microprocessor to peripheral, because addresses are generated by microprocessor. If microprocessor only will tell what is the address of input, what is the address of output, and what is the address of memory. As you all familiar with memory, memory is just like your notebook page. In this you have lines, so in memory also it is just like, each line is just like location where you can store data. And if I put numbers, unique number to these location, then these will be the addresses of your memory. Okay, so this one is one line of your register page, notebook page is just like a one location in the memory. And if I give number to that, so these are unique numbers or addresses of each memory location. So we have addresses for input device, we have the addresses for output devices, and we have the addresses of all memory location. Okay, so these all addresses are with 8085 microprocessor. The microprocessor is basically send the address where we need to transfer data. See, when we need to transfer data, transfer of data is done in 3 steps. First, the microprocessor will generate the address कि ये किसका address है जहाँ से data transfer होना है. Understood? For example, if input wants to send data, so input address should be generated by microprocessor. microprocessor. So microprocessor will send the address to decoder unit. We'll have diagram there. We will see address which is generated by microprocessor will transfer into where it will transfer to address decoder. Decoder will decode the address. What is the what is the peripheral address किसका है? This is the address of whom? This is the address of input or output or memory location. For example, if we are taking input, so this address is for input. Then we have one special line which we call chip select line. So that chip select line will select that particular input device. Because see, in your previous diagram, if you see this, buses are connected with every peripheral. So if the address is for input, then others should not get that address. Others should be in disable condition. And that disable we can automatically done by microprocessor क्योंकि हर एक line जैसे address bus है, this is of 16 bit. So we have 16 buffers, okay, which is in tri-stated mode. Now this term is very new for this tri-stated mode, or buffer is basically just a storage place to transfer data. Means हर एक लाइन के साथ एक बफर लगा होता है just to hold the data for a small period of time. Okay, very small period of time. तो जो वो डेटा है यहाँ पर अगर एड्रेस इनपुट का है तो एड्रेस विल नॉट ट्रांसफर टू मेमोरी, तो जो उसके बफर्स हैं वो ट्राई स्टेट मोड में चले जाते हैं. एंड दैट ट्राई स्टेट मोड इज बेसिकली द हाई रेजिस्टेंस मोड. The high resistance means resistance that oppose the flow of current. So it will not allow to transfer that signal to peripheral. So only the address will transfer to input device, not to memory and not to output device. And this is done by due to tri-stated buffer. कि chip select line जो है अगर वो input select करता है तो address bus पे जो address है that will transfer to input device, not to memory and not to output device. Understood? So unidirectional means address is generated by microprocessor only. Understood? And the length of my address bus is 16 bit. Okay, every microprocessor has its own address bus length. Like in your i3, i5, they are having 32 bit address. Okay, so in 8085 microprocessor, we have 16-bit address. The length of address bus is 16-bit. So based on this 16-bit, it tells the amount of memory a system can address. ठीक है ना? अभी address of memory कैसे पता चलेंगे? As I told you that this is basically consists of location. Okay, it is just like your page of your notebook, and if I give address 0 1 2 3 like that, so these will be the addresses. So how many addresses we can have in memory, that we can determine with the help of address bus. If address bus is 16-bit means 2 raised to the power 16. How many combination I can have? 65,536. Means if I start from 0 1 2 3, तो कितने मेमोरी लोकेशंस मुझे मिल जाएंगे? 6 5 5 and last location का address क्या होगा? 65535 since we are starting from 0. Okay, ये total location है 65,536. But if you start, because digital electronics from 0 से start करते हैं, so this is the address of first memory location. This is the address of second memory location. तो last address क्या हुआ? 65,535. ओके, तो आप इसको 64 KB भी लिख सकते हैं. 64 KB means if you split 2 raised to the power 16 into 2 part, 2 raised to the power 6 into 2 raised to the power 10. Okay, so you can split like that. So 2 raised to the power 16, how much it is? It is 64. Okay, or 2 raised to the power 10 is how much? It is 1024, which we are saying 1000. K, it denotes किलो, 1 किलोबाइट, 1024 क्या होता है? इट इज के. तो हमारी मेमोरी कितनी हो गई? 64K. Now what is B over here? B stands for bytes. Bytes means 1 byte is equals to how much? It is 8 bit. How many bits? 8 bit. Means every memory location can store how many bits? It can store 8-bit information like that. That's why it is 64 kilobyte. Means 64K into 8 bit. अंडरस्टूड. तो हमारा जो मेमोरी है, कितना मेमोरी हम उस प्रोसेसर के साथ एक्सेस कर सकते हैं, that depends on address bus. So in 8085 our address bus is of 16 bit. If it is of 16 bit, so how many locations you will have? 2 raised to the power 16, 65,536. और how मेमोरी कितनी बन जाएगी? 64 KB. B stands for bytes, means 1 byte, और 8 bit you can store in each location. उसका भी रीजन है क्योंकि 8085 का डेटा बस डिपेंड करता है इस पे. इफ 8085, अभी हमारा नेक्स्ट जो टॉपिक है डेटा बस, इट इज ऑफ 8 बिट. 8 बिट मीन्स 1 बाइट. डेटा बस कितनी है? 8 बिट है. तो हर, तो वी कैन ट्रांसफर 8 बिट डेटा. ALU साइज 8 बिट है, वर्ड साइज 8 बिट है, तो हर एक मेमोरी लोकेशन भी कितने बिट की होनी चाहिए? 8 बिट. सी, इफ यू आर गिविंग डेटा, that data is in 8 bit form, so it will transfer through data bus. So data bus should be of 8 bit. It will go for processing, so 8 bit simultaneously go to your ALU size should be of 8 bit. And after processing, if it is storing in the memory, then your register, memory location, everything is of 8 bit. Understood? Now this range which I have written, it is in decimal, but our kid don't understand decimal number or binary number. 16 bit stands for that you have 16 binary numbers, okay, binary digit. बट अवर किट जिस पे आप प्रोग्रामिंग करोगे, वो किट को सिर्फ समझ आते हैं हेक्साडेसिमल नंबर, बिकॉज कीपैड इज ऑफ हेक्साडेसिमल नंबर. तो वी नीड टू कन्वर्ट दिस इनटू हेक्साडेसिमल. तो उसके लिए हमें क्या करना पड़ेगा? वी नीड टू यूज द कन्वर्जन मेथड दैट वी हैव ऑलरेडी डन. ओके, so I'll share whiteboard with you so that I can write some numbers. Okay, so if I'm writing here 0, so how to write 0 in binary if your data address bus is of 16 bit? So means 16 zeros you need to write as a address of your first location. That can be understand by microprocessor, but your keyboard is of hexadecimal. So how you to write or how you transfer your data through hexadecimal keyboard? तो उसके लिए कैसे करेंगे? We need to convert this binary into hexadecimal. So how to convert binary number into hexadecimal? By making group of 4 bit. तो इस तरह से ये 4 bits का 1 0. Understood? 1 0. दूसरे 4 bits का this 4 bit is again 1 0. This 4 bit again 1 0, and this 4 bit again 1 0. Means to represent 16-bit binary with the help of hexadecimal number, you need 4 hexadecimal digits to represent. See, I am doing this in very detail because आपको प्रैक्टिकल में ये हेल्प होगा और थ्योरी के प्रोग्रामिंग लिखने में भी it will going to help you. Okay, so first which I have written here 0, it is in decimal. Then I have converted this Same way, if I want to write 1 over here, then how it will come in binary? 0 0 0 0 0 0 0 and 0 0 1, right? And how to write in hexadecimal? In hexadecimal, this will be 0 0 0 1 H. See, H is the unit to represent hexadecimal. Same way, if I want to write 2 here, so 0 0 0 0 0 0 0 0, this will be the language of microprocessor. Okay, तो हम इसको हमारी लैंग्वेज क्या है हेक्साडेसिमल. तो इन हेक्साडेसिमल में हाउ विल आई राइट 0 0 2 H. Understood? Okay. If I want to write 50, then computer की language में this is, or what is the code for 50? Anyone? 111, right? F का कोड था ना 4-bit concept में. Now how to write in hexadecimal? What is the address? 0 0 0 H is the representation, which is not the part of your address. Now 16, if I want to write, can anybody tell 0 0 0 0 0 0 0? How to write 16? How to write 16? Anyone? Very good. 1 0 0 0. From Anirudh also 1 0 0 0. Right. Okay. So here I am writing 1 0 0 0 1 and this will be 0 0 0. And in hexadecimal कैसे लिखेंगे यहाँ पर? माइक कैसे लिखेंगे यहाँ पर? What is the code? Right. Very good. 0 0 1 0 H. Understood. Now the last location 6 5 6 5 5 3 6. So when you convert this into decimal, so what it will come? It will come 16 times 0 ones. Convert and see. 65,500, sorry, 35. This is we are starting from 0. So when you convert it into decimal, when you convert this decimal number into binary, that 16 times ones will come. Now what is the hexadecimal code for this? With a group of 4. So what it will come? Very good. So F F F F. Right? So this is your addressing scheme in 8085 microprocessor, that it is starting from it is starting from FFFF and from 000 000. So means your addressing scheme is from 000 to FFF. Okay. So I'll stop sharing this. Okay, so understood this. So now I'll show you the kit. If we kit दिखाते, then it will be more clear why we need this hexadecimal address. Then I'll start with this. See, now you can see this is front view. You can say the top view of your kit. ये है आपका display. This is your display, right? In this first 6 segments you can show, you can see 7 segment display. The first 4 is representing address. Okay, first 4, that's why your why this 4 digit we need, क्योंकि हमारा address क्या है 00002. Yes Harshit. No, I'm not getting this. Please remove this window. Okay. Let's see. So this is your address area where address will going to display. So why it is 4 digit? Because you have address of 16 bit, and 16 bit in hexadecimal need 4 digit. So if I want to write address, let's say यहाँ पे लिखा हुआ है, that is the address of your memory C000. This is the address, and here you will going to store your data, because data bus is of 8 bit. So 8 bit को when you convert into hexadecimal, then it will be represented by 2 digit in hexadecimal. So that's why we have a display. यही हमारा display है. Whatever we will enter in this kit in hexadecimal form, and the result also will come in hexadecimal form only. See, if you can see this part, this part is basically what? It is your keyboard. It is not a normal keyboard, it is hexadecimal keyboard. Only 16 keys are there. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E and F. These 16 keys are there in hexadecimal. इसी से आपको अपना प्रोग्राम एंटर करना है और एग्जीक्यूट करना है. प्रोग्राम यू विल राइट in the form of mnemonics. Second chapter mein we will learn all 74 instruction, and all 74 instruction are in the form of false code like add, sub, move, that we cannot enter here. So we have one hexadecimal chart where you will have all 74 instruction hexadecimal code. Okay, you have to refer code. जैसे मैंने लिखा एक instruction, add instruction. So add instruction, if I am writing, so I am using this mnemonic in a programming, that addition of two numbers, subtraction. So if I am writing add B, see I am adding two number like that. Okay. So if I am adding, so I cannot put that add here. I cannot type add here. So I have hexadecimal code in one table that we will give you during the time of exam. Board exam, theory exam में we don't require hexadecimal code, only we need to write mnemonics. But for practical, since we have to enter in the kit, so we need the hexadecimal code of that particular mnemonic. So for that we will have that table, and you need not to learn any hexadecimal code. वो आपको आपके टेबल पे मिलेगी किट के साथ ही. आपको सिर्फ प्रोग्राम लिखना है, कोड उसमें से सर्च करना है, और you have to enter in this kit. Understood? ये जो आपको दिख रहा है, that is 8085 microprocessor kit. 8085 microprocessor IC, 40 pin IC. And this area, if you can see this area, this is your RAM or ROM. This white chip जो है, that is EEPROM, where all permanent information like all 74 instructions are stored here. Okay, and ये है आपका RAM where you will going to write your program. तो जो भी आप यहाँ किट से enter करोगे as a user program, that will store in this RAM area. Okay, this place is empty, means you can upgrade or you can add more memory just to save the cost. University level तक ये प्लेस खाली ही रहता है, क्योंकि प्रोग्रामिंग बहुत छोटे छोटे प्रोग्राम्स हम एग्जीक्यूट करते हैं, तो वी डोंट रिक्वायर मच मेमोरी, तो वी कैन जस्ट रिड्यूस द कॉस्ट ऑफ 500 to 1000 rupees due to this one. Okay, so बहुत सारी supporting ICs है that we will do later on in theory part of this 8085 microprocessor. तो इस तरह से आपका ये किट दिखता है, और आपको जो भी प्रोग्रामिंग करनी है वो हेक्साडेसिमल में ही करनी है. Okay, now this one, address data, now it is clear I think to you that it is a group of conducting wire which carries address. It is unidirectional, it is 16 bit, and it, because due to 16 bit you will come to know the address, how many locations we can address. It can be 64 kilobytes, and address range in hexadecimal, which we are going to use in for programming. It is 000H2 FF. Now this is all about address bus of 8085 microprocessor. Okay. Now next is data bus. Data bus is, as its name is saying, data, it carries data. Okay, so data जो है, it carries data only, and it is bi-directional. Address bus was unidirectional and data bus is bidirectional. Why data bus is bidirectional? आपने ये डायग्राम देखा था, ब्लॉक डायग्राम. Okay, so in this, if I want to transfer data from input, it will one way from input to main memory. But from main memory, it will go for processing. After processing, it will come back again in the main memory. So here it is two way. And from main memory again, it will go to the output device. Then it is again one way. So somewhere it is one way, somewhere it is two way. So we consider data bus as two way due to this, because here it is two way only from main memory to ALU for processing. After processing again on same lines it will come back to main memory. So that's why data bus is bi-directional. Now next is data bus is of 8 bit. Okay, as we have already seen in evolution, और हर एक प्रोसेसर के अपना अपना वर्ड साइज होता है डेटा बस. So it tells the word length of microprocessor, means how many bits it can process at a time. It is basically called the word size और word length of microprocessor. तो डेटा बस से ही जाना जाता है कि वर्ड साइज कितना है. जैसे i3, i5, i7, पेंटियम, इन सब का 64 बिट डेटा बस. 64 बिट मीन्स एक वर्ड जो है उसमें वो कितने बिट का होगा, मीन्स इट कैन प्रोसेस 64 बिट साइमल्टेनियसली. तो यू कैन इमेजिन नाउ 2 रेज़ टू द पावर 64 कितना वर्ड साइज और कितने टाइप के combinations we can use for different words. Okay, so here it is 8 bit, means 2 raised to the power 8, that means 256. 2 raised to the power 8 means 256 combinations I can make, means 0 to 255. ओके, तो सेम वे जैसे हमने एड्रेस के लिए लिखा था, तो अगर मुझे यहाँ पे जीरो लिखना है तो हाउ मेनी टाइम्स इन बाइनरी आई विल राइट 8 zeros I should write. Okay, when I use 8 zeros in binary, then how will what is the representation in hexadecimal? Same way you have to make the group of 4 bits. So when you make the group of 4 bits, so you will get 2-digit hexadecimal number, this 00FFH. अंडरस्टूड. तो इसीलिए आपने किट पे देखा लास्ट के टू जो डिस्प्ले है वो 2 डिजिट, 6 डिजिट क्यों है, 4 डिजिट एड्रेस के लिए and 2 digit for data. Clear? So that is your data bus. Next we have last bus, or we can say control line. Control line is basically, it is used to generate timing and control signal. Why it is line, why it is not bus? Because it is a single signal. That's why. And bus is basically group of line, but it is a part of your bus structure. It is basically used to generate timing and control signals to all the associated peripherals. कि when to flow data, इनपुट रीड है, रीडिंग फ्रॉम इनपुट, आईओ रीड राइट है, राइटिंग टू आउटपुट, मेमोरी रीड है, रीडिंग फ्रॉम मेमोरी मीन समथिंग इज देयर इन द मेमोरी एंड यू आर accessing. Writing onto the memory means memory write hai, means you are writing something onto memory or storing something. तो उसका जो flow of control है that is maintained or synchronized by control line. So these are three buses: address bus, data bus and control bus, which is used to connect all the peripherals with microprocessor for communication to transfer data here and there. So that is your third question: what is microprocessor and what is bus, and describe the bus structure of 8085 microprocessor. Now last question from this topic is draw neat and label diagram of microcomputer. Now microprocessor का block diagram किया था छोटा सा ALU register and control unit. Now in microcomputer you will not draw that basic diagram. ये वाला diagram you will not draw. Okay, this is just for reference. Primary secondary section में हम पढ़ते हैं, but for your exam purpose, this you have to draw, it is there in TPS. I have also taken from TPS only. So in this, everything is same, just the way it is connected, it is different. Like, so if you see this, one minute, I'm just going to, I'm not able to see this. Okay, if you see this part, that this is your input. Input device is connected through input interface. Means whatever the data you are giving from input, it will convert into binary through interface. This is your microprocessing unit MPU. Okay, your CPU you can say, or ALU. This is your main and ROM memory, RAM and ROM, and this is your display interface. From this, it will again convert from binary to hexadecimal. So if you can see, input, CPU, memory and output all are connected in single line. ठीक है, vertically they all are connected. पहले वाले में क्या, input इधर है, output इस side, बीच में CPU, इस तरह से connected है. ठीक है. So Abhi, how they are connected to each other? Now if you can see in this, they are connected through address bus. This is your address bus. This is your data bus, and clock signal is giving control signal. So it is generating, clock signals are generated by this clock circuit, and this will transfer to AMPU, and MPU is basically giving this control to, or controlling all the parts with the help of this control signal. So the single line is connected with all the peripherals. Understood how it is working? In this, MPU will send the address. Address decoder will decode the address, and after decoding, it will select this chip select line. क्या करेगा? Chip select line is connected to everyone. तो जैसे ही decoder decode करेगा कि okay, it is the address of keyboard, तो chip select line will activate keyboard, and other will be in disable. मतलब उनके buffers किस में रहेंगे? Tri state form में they will be there. Okay, and जैसे कीबोर्ड एक्टिवेट होगा, it will transfer the data, and this is power supply line जो कि हर एक के साथ connected है. So this way you have to connect your all the peripherals to address bus, data bus, control line,